The universe has existed for 13.8 billion years. It will not exist forever. These are 10 ways everything could end. Number 10. The Big Crunch. Right now, the universe is expanding. Every galaxy is moving away from every other, carried apart by stretching space. But expansion is not guaranteed to continue. If gravity eventually overpowers the expansion, every galaxy would begin falling toward every other. Distances would shrink. Galaxies would collide and merge. The sky would grow endlessly brighter as the universe compressed, until there was no distinction between night and day, just blinding light from every direction. Temperatures would rise without limit. Atoms would be stripped apart. Atomic nuclei would dissolve. The entire compressed plasma of the universe would converge toward a single point of infinite temperature and density, the Big Bang, but in reverse. The Big Crunch is currently considered unlikely given that the universe's expansion is accelerating, but it remains possible under certain models of dark energy if its behavior changes over cosmic timescales. Number 9. Heat death. Of all the endings, heat death is the most certain and perhaps the most quietly horrifying. The second law of thermodynamics says entropy always increases. Energy flows from concentrated forms to dispersed ones and never reverses on its own. Stars exist because hydrogen is concentrated. Eventually, that hydrogen runs out. In roughly 100 trillion years, the last star will go dark. No new stars will form. The universe will be white dwarfs, slowly cooling. Neutron stars, black holes drifting apart in permanent darkness. Over further timescales, even white dwarfs will become cold black dwarfs, radiating nothing. Black holes will evaporate through Hawking radiation. In the end, the universe will reach thermal equilibrium, every point in space the same temperature, approaching absolute zero. No energy difference anywhere, no event possible, no structure, no motion, not an explosion, not a collapse, just perfect, permanent stillness. Number 8. The Big Rip. Dark energy is accelerating the expansion of the universe. If dark energy strengthens over time rather than remaining constant, a form called phantom energy, the expansion eventually overcomes every other force, one by one. First, galaxy clusters would be torn apart, then individual galaxies, then solar systems. In the final minutes, planets would be ripped from their orbits, then shredded as dark energy overcame electromagnetic forces. Molecules would separate. Atoms would be torn apart. In the last fraction of a second, atomic nuclei would rupture, the strong nuclear force would fail, and space-time itself would tear. Current measurements do not confirm phantom energy, but they don't rule it out. The Big Rip could occur in roughly 20 billion years if the numbers are slightly different from what we currently measure. Number 7. Black holes take over. Long after the last stars die, black holes will dominate the universe. For quadrillions of years, they will be the only significant structures remaining, slowly consuming any matter that drifts close. But black holes are not permanent. In 1974, Stephen Hawking demonstrated that black holes emit faint thermal radiation through quantum effects near the event horizon, slowly losing mass. A solar mass black hole would take 10 to the power of 67 years to fully evaporate. Eventually, every black hole evaporates. The last one shrinks to nothing in a final burst of gamma radiation. After that, only cold diffuse radiation remains, spreading outward forever in a universe containing nothing else. Number 6. Vacuum decay. The vacuum of space has an energy state. There is no guarantee it is the lowest possible. Our vacuum may be a false vacuum, stable enough to have lasted 13.8 billion years, but not truly at its ground state. If a quantum fluctuation pushes a tiny region of space into a lower energy state, that region immediately begins expanding at the speed of light. This bubble doesn't destroy matter, it rewrites the laws of physics. Inside it, particle masses, force strengths, and the rules governing atomic structure would be different. Chemistry as it exists would cease to function. The bubble travels at the speed of light. No warning is possible. One moment, the universe exists normally. The next, the bubble wall arrives and the physics permitting your existence are replaced. No explosion, no heat, no pain. A different universe, instantaneously. Number 5. False vacuum collapse. Related to vacuum decay, but triggered rather than spontaneous. If the universe's vacuum is not at its minimum energy state, a sufficiently energetic disturbance could push it there. An extreme collision, a cosmic-scale energy release, or possibly the technology of a sufficiently advanced civilization. In the true vacuum, the Higgs field settles to a different value. Every electron in the universe would change mass. Electromagnetic force would shift. The rules holding atoms together would be rewritten. Atoms would not be destroyed. The laws permitting them to exist would simply no longer apply. Matter would dissolve into a formless sea of particles obeying a completely different set of physics. Unlike spontaneous vacuum decay, spreading from one point, a triggered collapse could restructure the vacuum of the entire observable universe simultaneously. Number 4. Gamma-ray burst. The previous scenarios end the universe. A gamma-ray burst ends life within it. When a massive star collapses into a black hole, or two neutron stars merge, the resulting burst releases more energy in seconds than the sun will emit in its entire lifetime, focused into two narrow beams of gamma radiation at the speed of light. A gamma-ray burst aimed at Earth from within our galaxy would strip the ozone layer from the facing hemisphere within seconds. Ultraviolet radiation would flood the surface unimpeded. Photosynthesis would collapse. The food chain would unravel from the bottom. Some researchers believe a gamma-ray burst may have contributed to the Ordovician extinction 450 million years ago, one of the 5 largest mass extinctions in Earth's history. Our galaxy currently contains no known immediate threat in the right configuration, but the galaxy is large. Surveys are incomplete, and the universe beyond has already witnessed countless such events. Number 3. The simulation hypothesis. Every scenario so far assumes the universe is physical. But one possibility, and taken seriously by researchers at institutions including MIT and Oxford, is that it isn't. If the universe is a computational process running on some external system, then the laws of physics are the rules of the simulation. Matter, energy, space, and time are not things that fundamentally exist. They are processed information. In that case, the universe could end in ways that have no physical mechanism. The simulation could be terminated, crash, or simply be allowed to stop. There would be no warning, no physical process to detect, no heat, no compression, no tearing. The universe would simply stop. Every particle frozen, every thought unfinished, because the process running it ended. This is not a scientific theory in the conventional sense. It cannot currently be tested or falsified, but it has not been ruled out. And if advanced civilizations can create simulated universes and do so frequently, then statistically, the probability that any given universe is the base reality approaches 0. Number 2. The Big Bounce. The Big Bounce is not a destruction scenario. It is stranger, the possibility that the universe doesn't end at all, but cycles continuously through collapse and rebirth. In some models, the Big Bang was not the beginning of everything. It was a bounce, the moment when a previous collapsing universe reached maximum compression and rebounded outward. Our universe is one cycle in an infinite series. Loop quantum cosmology provides a possible mechanism. At extreme densities, quantum gravitational effects would prevent complete collapse to a singularity. Instead, the universe would reach minimum volume and expand again. If correct, the Big Bang was not creation. It was a transition. The universe before ours compressed to a point and gave rise to everything we see. The universe after ours will emerge from our ending. Every galaxy, every star, every atom, one breath in an eternal cycle, carrying no memory of what came before. Number 1. Proton decay. Every scenario on this list, every galaxy, every star, every planet, every living thing is made of matter, and matter is made of protons. In the standard model, protons are stable. They do not decay. They do not break down. Grand unified theories, frameworks attempting to unify the fundamental forces, predict otherwise. They predict protons will eventually decay spontaneously into lighter particles. The predicted half-life ranges from 10 to the power of 31 to 10 to the power of 36 years. The Super Kamiokande detector in Japan has monitored 50,000 tons of ultra-pure water for decades, watching for a single proton decay event. None has been observed, but absence of observation is not proof of permanence. If protons do decay, then long after the last stars, long after the last black holes, in a universe of near total darkness and near total emptiness, the final matter will quietly dissolve. One by one, protons will convert into positrons and pions. The last atoms will cease to exist, not destroyed, not collapsed, not ripped apart, simply gone, particle by particle, in perfect silence. The universe will not end with fire or collapse or an instant of impossible brightness. If proton decay is real, it will end the way a dim light ends, slowly, patiently, without witness, without sound, until the last particle of everything that ever existed finally lets go.